video, we are going to explain semantics of data mining services in cloud computing. Introduction. Data mining and machine learning services are being integrated into cloud computing systems. It underscores the difficulties caused by different service descriptions among providers and emphasizes the necessity for a unified data mining service definition. It gives a semantic approach for service description that addresses the management issues as well as data mining activities. The proposed approach is viewed as an important step toward the standardization and industrialization of data mining services. The introduction briefly addresses the validation using existing service descriptions as well as an example using random forest method. Coming to objective, the project's goal is to build a system that uses cloud services to deploy and access the machine learning algorithms. Its goal is to make the process of combining services from diverse cloud providers easier by providing remote deployment and access to algorithms via service access URLs. The project focuses on the cost, effectiveness, flexibility, and usability of cloud-based systems, particularly in healthcare and banking. It also offers functions to expedite the deployment and access process while taking security and price into account. Finally, the project aims to show the utility of cloud-based machine learning services for data mining jobs. For execution of the project, we need these requirements. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. In software requirements, Python IDE of 3.7 version we need. These are the design modules for execution. In cloud, this module will upload diabetes dataset and then train the random forest algorithm and then publish the cloud service. This service will accept input from user and then apply random forest to predict disease from test data. Second module is user. This application will upload test data and then connect to cloud services and then send test data to cloud, and cloud service will predict disease from test data. For execution of the project, first we need to open the code folder. This is the code folder of the project. In this we have two folders. First one is cloud machine learning. In this we have the dataset. For this dataset we will be training the algorithm. These are the parameters of the data, which are pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, prediction function, age, outcome. And these are the data. 1 means the person has the disease and 0 means the person don't have the disease. And this is the Python main code file and this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. And this is the another folder. In this also we have the data, which is test data. For this data we will be predicting the algorithms. These are the data points. Here we will not have that label, which is the person is not having disease or having the disease, which means 0 and 1 values. And this is the run.bat file and this is the Python main code file for this folder. First we need to run the run.bat file in cloud machine learning folder. This is the graphical user interface of the project. With this we will be interacting with the program and this is created by using Tkinter library. So first we need to click on the button upload diabetes dataset to upload the data. So here I am selecting the data and clicking on open. Here the blue line is confirming that the dataset is uploaded. Now we will be pre-processing this to remove the missing values and also to standardize the data. Here missing values are removed and the dataset length is 768 and the training length is 691 and testing length is 77. Initially, the random forest model will train on this dataset, which is training dataset, and then it will predict it on testing dataset. Now we'll click on the button train random forest algorithm to train random forest approach. So here we got the accuracy of random forest algorithm. So now to predict the test data, we need to click on the button start cloud server and publish CCDM service. So this cloud server will start running in infinite loop to receive requests from user, and now after clicking on this we need to click on the button run.bat file from user folder to start user application. So here I will select the user server. Now I will run this run.bat file. So here Now I need to click on upload files button to upload test data, and then user application will connect to cloud service and then send request, and cloud service will predict disease using random forest and send response back to the user. So here I am selecting the dataset and clicking on open. Here we got the predictions. For this particular user and with these values, it is predicted that abnormal values are predicted, and here disease is predicted, which means the class label is 1. And if the disease is predicted, we have the diet plan details. Here is in picture format. And for this particular user ID, he don't have the disease. Here it is predicted as normal values. Predicted values is 0 and no disease predicted. Similarly, we can test with other datasets also. Similarly, in any cloud service provider, we can build such application and then publish URL, and then use application can access that URL to get prediction from machine learning algorithms running on cloud. Client or the user application can choose service URLs based on authentication, pricing and security. Here, clouds are not free, so we built our own cloud. And if we have multiple clouds, then we have to choose service based on pricing. I will close this picture. Conclusion: the project emphasizes the importance of combining data mining and machine learning services with cloud computing platforms. This method provides practical benefits such as cost saving, virtual resource supply, and improved accessibility. The proposed semantic scheme for service description is positioned as promising step toward standardizing and streamlining data mining services, ensuring usability and compatibility across diverse cloud providers. The scheme viability and potential impact are reaffirmed through service descriptions and practical illustration. The conclusion emphasizes the project's importance in enabling many sectors such as healthcare, banking, to efficiently employ cloud-based machine learning services. It emphasizes the ability of the customer to select services based on authentication, pricing and security, which contributes to general advancement of cloud-based data analysis capabilities.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.